Welcome to David Alexander Maths Tuition. This is chapter 7G, Modelling with Trigonometric Functions. Okay, so here's an example. The temperature T in degrees Celsius at a coastal city during a 12-hour period can be modelled by the function T is 22 plus 4 sine 0.5T minus 1.2, where T is the number of hours after 6 a.m. and angles are measured in radians. Find the temperature at 6 a.m. and 6 p.m. So we just need to be a little bit careful. I mean, these sort of questions are almost deliberately annoying because we've got a big T for temperature and a small t for time. So let's not get them confused. So the temperature at 6 a.m, well, how many hours after 6 a.m. is 6 a.m? Well, that's 0 hours. So here, little t is 0. So all I need to do is substitute, I just need to do 22 plus 4 times the sine of 0.5 times by 0, take away 1.2, and 22 plus 4 times the sine of, 0.5 times 0 is 0, so that's just the sine of minus 1.2. Of course, worth double checking that you are in radians and not degrees, and that works out as 18.27 degrees Celsius. Okay, when at 6 p.m, then T is going to be 12, so it's a similar calculation. We, instead of doing 0.5 times 0, it's going to be 0.5 times by 12, or just 0. Or 6, take away 1.2, and then we are getting, so this is 6 a.m, and we'll be getting 18.02 degrees C at 6 p.m. Normally these sort of questions I would have expected a slightly more substantial difference between those two answers, but there we go. Okay, so for this part of the question we need to calculate the maximum temperature and the time at which it occurs. Well, the sine of anything will always have a maximum of 1 and it will have a minimum of -1. We're not interested in the minimum, but maximum 1, minimum -1. 4 times the sine of anything will have a maximum of 4 and a minimum of -4. And if we're adding the 22 onto it, that means we're just shifting this whole graph up by 22 units. So the maximum will be 26 and the minimum will be 18. Okay, so the maximum temperature we've calculated to be 26 degrees C. And what is the value of little t when we get 26? Well, it's when this whole equation equals 26. So therefore 22 plus 4 times the sine of 0.5t, take 1.2, equals 26, in which case 4 times the sine of 0.5t, take away 1.2, equals 4, and the sine of 0.5t, take 1.2, equals 1. So therefore 0.5t take away 1.2 is the inverse sine of 1, which is pi over 2, and then 0.5t will be pi over 2 plus 1.2, so pi over 2 plus 1.2, that is 2.77, so I'm going to double it for t, so t is going to be 5.54 to 2 decimal places. Now be careful here that your calculator doesn't know that t is time, so the time is not 5:54, it's 5.54 hours later. So after 6 a.m, that's 7, 8, 9, 10, 11. So the time at which it occurs is 11, and it's not 11:54. This is 0.54 of an hour, so it's just over half an hour. So it's going to be 30 something minutes. So what I would do here is just take away the 5, because we know the 5 whole hours is fine. So I've got, it's what is 0.54 of an hour, or 0.54, multiply that by 60, and we get 32 minutes. So the time at which it occurs is 11:32, and we should probably state that that is in the morning. And for the final part, a tourist wants to go hiking when the temperature first reaches 3 degrees above the day's lowest temperature. Well, from the previous question, we worked out that the maximum was 26 degrees and the minimum was 18 degrees C. So therefore, the hiker wants to go hiking when it is 21 degrees C. So we need to make this equation 22 plus 4 times the sine of 0.5t minus 1.2. We need that to equal 21. So what we're going to do is we are going to subtract 22 from both sides. So that will leave -1. And now I'm going to divide through by 4. So sine of 0.5t minus 1.2 is -1/4. So I'm going to inverse sine that. -1 divided by 4, shift to sine answer. So therefore 0.5t take 1.2 is minus 0.25 to 2 decimal places. Now I'm going to add the 1.2 and then double it. So therefore t is 1.89. So it's 1 full hour and 0.89 of an hour after 6 a.m. So if I add on that 1 hour, then that will be 7. So it's going to be 7 something. Obviously it can't be 7.89. That doesn't make sense. It's 0.89 of an hour. So I'm going to subtract the 1 from the 1.89. So I've got 0.89 of an hour times by 60 to turn it into minutes. That is 50. I've rounded to the nearest minute, and that is 54. So they should begin their hike at 7:54. All seems very particular. But anyway, it's just a maths question. So yeah, there we go. That's the time they should begin their hike, 7:54, and not a minute earlier.